Hello guys. So let's see the problem. Cheapest flights within K stops. So let's see the problem statement. So there are n cities connected by some number of flights, and you are given array flights. So as you see in the example number one, this node zero, node one is denoting to the cities, and this pointer is basically denoting to the flight. It means that from node 0 to node 1 there is a flight with a cost of 100 rupees or with a cost of 100. Okay. And also three integers variables are given. So these are source, destination and k. And we need to find out the cheapest price from source to destination with at most k stops. Okay, and if there is no such route, return -1. Okay, so let's see the example number one to clarify what this problem is saying. Okay, so here if you see like my source node, so source is 0 and destination is this 3 and k. So k is basically 1. So here it means that from source in between source to destination node, that is 0 and 3, at max one stoppage is allowed. It means that I can only take a stop at max one, at least at max one node. Okay, so let me do a dry run. How the answer is here 700 to see. Okay, so now 0. So if I start, so if I go from 0 to 1, then the cost is 100, and up to node 1 I used one stoppage. Okay, from here two paths are there, like I can go to the node 2 and I can go to the node 3. So if I go to the node 2 and then I go to the node 3, the cost path, the path cost is 100, and 200, that is 400. And if I use this path 0 to 1 and then 1 to 3, then the path cost is 700. Now the minimum cost is 400. But as you see, answer is 700 because the value of k is 1. It means that at max one stoppage is allowed. But if I use this path 0, 1, 2, and 3, then here two paths, two stoppages are there in between the source and destination. So that's why we are not allowed to go through this path. So there is only one path left, that is 0 to 1 and 1 to 3. So only that's why the answer is 100 plus 600, that is 700. Okay, now let's what is the idea. So this is all about the problem statement. Now how to solve this. So if I talk about now in the problem statement, it is saying that the cheapest price. Okay, but in the example number one, we have seen that the cheapest price is not working. We have to also take care of the k stoppage condition. But if I use, like if I use go with the Dijkstra, then what will happen? So it will give us the wrong answer. If we only consider Dijkstra, we have to use the modified Dijkstra. And what about the modification? So basically the modification is we have to use in such a way so that we are allowed to update the node at max k times by using a priority queue. Like the Dijkstra is all about using a priority queue, and not only not only seeing the minimum path, minimum cost path is time, we will also see the at max k stops condition. So that's what I tell you, like the overall complexity it becomes, normally the Dijkstra takes e log e v plus e log e, so now it will take e into k log e into k. Okay, but is there any other approach that is more good here, that work more better here? So yes, so if I use simple BFS, because we need to take care of both the shortest path, minimum path, and the minimum cost path, and the minimum number of stoppages. So basically we are e into k is the complexity if I use BFS. And for that for taking the shortest path, we can use a vector array container, so that we only choose the minimum cost path up to that node, means while traversing, while keep on going from source to destination. I hope the problem and the idea is clear. So let's see what I want to say you. I'm going to implement the coding part. So let's see. So yeah, so I'm going to do it by using a simple BFS. So before that, I need a adjacency list. So adjacency list and pair is required here because source to destination and also the cost path to store cost path. Yeah. Okay. So flights dot size and I plus plus. So basically it's a directed graph. So just need to adjacency flights I 0 dot pushback flight flights I1 comma flights I2. Yeah. So up to this, my adjacency list is ready. Now I need a one queue data structure, and I also need a distance vector distance. Initially, it initialized with int max. So just okay. In the queue, what I need to store? I need to store the current node. I need to store the minimum cost or the cost up to that node, or the number of steps, means the number of stoppage before that node or up to that node. Okay. So q dot push. So here I need a vector because I need to store three elements. So okay, so the source is the first element, the distance is 0, and the value of k is also 0 because we have started, so there is no any stoppage before that. Okay, so q dot empty. Okay, we need answer vector also, sorry, answer variable to store the answer. So we will update our answer variable each time. Okay, so vector int temp equals to q dot front and q dot pop. Now check. So temp, yeah, what is the current node? It's temp 0 equals to test. Then update the answer. Answer equals to mean of answer comma temp 2 because sorry 1 because the cost path is stored in the second index at the second index. Again yeah. So the next condition we will check if the number of steps up to that node is greater than k, then not required, there is no need to explore that node, or yeah, or to explore the adjacent nodes or the neighbor node of this current node. Okay, so if temp2 is greater than k, temp2 is greater than k, then simply continue, or else just explore all the neighbor nodes. So adjacency list temp 0. Now temp 0. So yeah, so first of all check distance. So distance id dot first, if the lesser than, yeah, not lesser than, if it is greater than the current means id dot second, id dot second plus this temp 1. If this condition satisfied, it means that we need to update the distance id dot first equals to id dot first equals to it dot second temp 1, and also push this node into the queue. So q dot push it dot first comma distance it dot first and temp 2 plus 1. Increment the number of steps. That's all. At the last, once the whole queue will be pop out, all operations will be performed. Just check if answer equals to int max. It means that there is no any path available. So just return -1 or else return answer. Okay, so let me run this. Okay, so the sample test cases are passing. So let me submit. So as you see, the solution get accepted. So yeah, so that's for this problem.